that, we actually have two pieces of evidence, kind of. Because I saw, say it one more time.
That if one or more of those areas is not connected, then the light bulb wouldn't light up.
So that's kind of like, we've almost got two pieces of evidence. What is another specific piece of evidence? So we've got that if one or more of those parts weren't connected, the light bulb didn't light up. How about someone give us another piece of evidence? Yeah.
You said when all 6 parts were connected and in a complete circuit, the bulb did light up.
You know, I just realized, so when all 6 parts were connected, the light bulb did light up. Could we revise something in our first one to make it even more specific? That if one or more of those parts weren't connected, the light bulb didn't light up. What could we revise in there to make it even more specific? Do you have any ideas? If one or more of those parts weren't connected.
Do we include a circuit?
Do we need to include circuit? That's a really good question. So if this was the very, we will pretend this is the very first lesson, which it is in this unit, the circuits unit. This is a 4th grade circuits unit. Do we want to include the word circuit? Do you think all of your 4th grade kids would know the word circuit in 4th grade? I don't know. Let's hold that thought. That's a good one. I'm glad you asked that. That's a good one. So that's a thought. Do we want to include the word circuit? We didn't really name the word circuit earlier. So let's hold that thought. Any other ideas about ways we can make that even more specific?
Could you just say if all 6 parts were not connected and the light bulb didn't light up?
Yeah, that's kind of what I was thinking, is adding up that 6. So if one or more of those 6, because we really talked about it's got to be the 6 parts. So adding 6 to make it even more specific. So you want your evidence to be really, really specific to reflect what the kids saw in the investigation. Is it hard for kids to use evidence? What do you guys think? Is it hard for you to use evidence? Yeah. Like, we're often used to doing these really cool experiments, but we don't actually do anything with the observations that we ask kids to make. So that's what we're going to be doing in this class, is using those observations as data, as evidence to answer the question. Okay? And trying to be as specific as possible. Okay. So that's our scientific explanation, our claim, and evidence. Ooh, then comes our reasoning. Our reasoning is kind of like the big science idea, the big scientific principle. Many of you were talking about circuits. Kyle was talking about transfer. You know, some big words that came up when you guys were doing this investigation. This is when those big words come up. Okay, and usually the reasoning is what I give you as a teacher. So the reasoning here, if you want to copy this down, feel free, is the science idea that helps me explain this is it's a complete circuit. Electric current can move through a circuit to light up a light bulb when 6 of the metal parts, as we said, tip and base of the bulb, both ends of the wire, positive and negative terminals of the battery, are connected in a circle. Some of you were talking about circle. So what we're doing here is we are naming what we saw after we saw it, rather than before we saw it. So now we're naming that this is called a complete circuit. What we created was a complete circuit. So, scientists, would you say these in the didn't light up column, are these complete circuits? Agree they're complete circuits or disagree that they're complete circuits? Okay, why? Prove it. Who can prove it? Kelsey?
All 6 parts aren't connected.
Awesome. So she uses her evidence that she saw from her investigation that all 6 parts are not connected. So these are not complete circuits. So these are complete circuits. Agree? These are complete circuits or disagree? Okay, prove it that they're complete circuits. Claire, can you prove these are complete circuits?
All 6 parts are connected.
Okay. You know, we could count them if we wanted to. So now is when we're using them. Now is when we introduce the vocab. So that may be a little different from how you learn to teach like literacy. So when you often introduce the vocab at the very beginning, and then the kids learn about it or practice it. In science, we give kids the experience, then we name the phenomenon. So the phenomenon was a complete circuit. We're naming it after we actually investigated it. Why do you guys think that is? Why in science do we name it after we investigate it? Ideas?
Kids need to be able to relate to the vocabulary, so by experiencing it, they have a memory of it.
Yeah, exactly. So you have some sort of frame that you can connect it to. So that might be something that we'll be thinking about as we move forward in this semester of science teaching. We often think about science teaching as like providing a definition, and then saying, "Hey kids, this is the definition of a complete circuit. Now let's go do the investigation to prove the definition I just gave you as the teacher." We're going to change things up a little bit, and it's going to be challenging because a lot of us, I learned science in terms of, hey, this is the definition of complete circuit. Now prove it with this investigation. So we're going to change things up. So that is the 5E model. And, oh yeah, I was going to ask you this. Reread your prediction quickly and share with your partners how is your explanation similar to or different from your prediction. Is it the exact same? What's different about it? Share with your partners.
Yeah, but like not, I was
with your colleagues. What was similar or different between your predictions and your explanations? Who would like to share? Who has not talked today? Anyone? In this class, I make you talk. If you haven't already realized this, students have told me in the past, like, wow, I'm not used to actually talking in class. Like, well, guess what? I'm going to make you talk. So, sorry if that makes you uncomfortable, but it's okay. If you're wrong, fine. So who would like to share what they discussed with their colleagues about how their predictions and explanations were similar or different? Okay.
We just said, for both of us, our prediction was a lot more like general and basic. So like I said, it'll make a circuit using a wire, battery, and bulb. I didn't specify like the bulb base or the tip. So I didn't list out the 6 things. I just had the general concept. And then at the end, it was much more specific using the vocabulary that you guys talked about.
Yeah, awesome. So your explanation will be much more specific, using the language that we share, we talked about, and also using the specific evidence. Great. Any other similarities or differences between your predictions and explanations? Was anyone's prediction way off? Like not right at all? Nobody? Come on. Was anyone's prediction kind of not right? Yeah. Okay, let's hear it. It's okay.
But I just said touching the wire to the positive side of the battery and wrapping it around the other end.
Yeah.
So kind of had a connection, but missing a side or two.
Yeah. What did you end up? What were you missing?
I mean, it could have been positive or negative, but I didn't have the other side of the battery connected, and not the tip, but the bulb.
Yeah. So, and it's okay if our predictions aren't correct. They will often be, and when I was teaching, I would have my kids write their predictions in pen because they want to go back and erase their predictions. And it's like, hey, it's okay. It's a prediction. It doesn't have to be right. And what is the benefit in your own, for you, what was your benefit in revisiting your prediction? What did you see? See what you didn't know. Anything else?
It just kind of shows that I actually learned something.
Yeah. It helps you actually realize you learned something. So what did you learn in this case?
Well, I learned that it takes all 6 parts and they have to be connected to make a circuit. I didn't know that it had to be every single one of those parts, obviously, from how a lot of did not line up.
Yeah, exactly. So it helps students know, learn what they didn't know. And that's one of the reasons also why, so this concept map that we created this morning, we will continue to revisit. You may redraw it, but we're going to revisit it throughout the course, kind of add to it so that you can see what you're learning about science teaching throughout the course. So it'll be kind of a document that is growing and reflects what you're learning about science teaching and the complexity of science teaching. So it's always good to have your kids, your students, revisit their predictions, and you may want to have them write those in pen because they get embarrassed and they'll erase them. Okay, so there's 2 other parts to this 5E. There's the elaborate. And talk with your partners just for a moment. What would happen if the wire was not stripped? So we talked about if it was just the rubber, plastic, at both ends. Talk about what would happen if that was the case. What about if your battery was drained and then the bulb was faulty, if it was your bulb didn't work? So talk with your partners about what would have happened if your materials would have reflected these issues. And why? Be specific. Don't just say,
All 3 of those parts, they keep happening. It's not like that.
Okay, so what did you discuss? What would happen if the wire wasn't stripped? It's obvious, but let's
Our
talk.
wire was actually not stripped.
Ooh.
One end wasn't stripped very well.
So we had to push it back because we couldn't get the metal part to touch the bone.
Yeah. So what can we say? What is important about that metal part? Yeah, it keeps that energy moving through, right? That transfer word that Kyle was using earlier that I want to return to. So it wouldn't allow the current to flow through. What about was the current able to flow through this glass? Nope. And we'll learn later. If this is a unit, we would say, wonder why. What is it called? You guys probably, I'm sure you all know. What is it called? What is glass and rubber? Insulators, right? We would talk about that in the unit. What about if the battery was drained? What would happen? It wouldn't work, right? Because there's no current, there's no push, there's no electrons moving through the current. If the bulb was faulty, let's say that the filament was. Does anyone know actually why the light bulb does? Oh yeah. why doesn't the light bulb work? What does it mean for a bulb to be faulty? Using what we learned today, when we have to replace our light bulb, so if we go back to my story of hanging out this summer and I had to replace my light bulb, why? What do you guys think? What does it mean for a light bulb to be faulty? Now that you have the scientific knowledge, what does that mean? Sarah, do you want an idea?
I'm talking a lot, so I'm sorry. But I know that, whenever I'm changing out a bulb, I notice that there's damage to the resistor. So that energy isn't able to flow, I guess.
So something about the resistor. So what part is the resistor?
The part inside the bulb.
Yeah, so we're going to learn about this is the resistor, which is also called a filament. Yeah. So something about damage to the resistor. So it's actually, it's like broken. So the filament is broken. So if a filament is broken, tell your partners, why would the light bulb not light up? Specifically, if the filament is broken, what would happen? So what's interesting in science is we often use these really big words like transfer, it wasn't a complete circuit, the circuit was broken. Like, what does that even mean? And so as teachers, you are looking for your kids to use these big words, and like Kyle was like using transfer, or complete circuit, or some of you were using this. What does that even mean? And so what happens as students, we learn, and as adults, we learn that our teacher wants to hear us use vocab, and we use it to like disguise what we don't really know. So I could say, hey, it's not lining up because it's not a complete circuit. Well, what in the heck does that even mean? It's not complete, or what does that even mean that it's like the energy can't transfer or flow through, or it's broken, or all these big words? You really want to press your kids and say, what do you mean it's not a complete circuit? What do you mean it can't transfer? Or what do you mean it's a broken circuit? So can someone tell us, not using big words, what does it mean that the light bulb can no longer light up, using the vocab that we discussed earlier? Okay, try it. Now you're afraid. Can anyone give us a try? All right, Charles, I'm going to call on you.
All right.
Do you mind if I call you out?
That's fine.
I think you can do it.
The light bulb won't light up because if the filament's broken, and that's kind of like having one of those 6 parts not being connected.
That's a great start. So it's like one of those 6 parts aren't connected, which means great. So can someone add to his explanation? So the current can't do what? Continue to flow through and complete the circuit. Yeah, because we knew it has to flow through all these parts. So because if it goes here, it can't flow through, it stops. Because remember, the current has to flow all the way up. And I should have brought in my light bulb. But it's pretty cool I have a light bulb that I cut open. And when you cut it open, you can see that a wire comes out here, like it literally comes out the side, and a wire goes down the bottom. So it really does the current really does have to go from here, and then go up through the filament. So that's pretty cool. So so it doesn't allow the current to flow through to light up that light bulb. Nice. Great job. Yeah. So we decided that so what else? Let's see. We sort of answered the hook. So if we go back to my story, the reason that the light bulb didn't work was perhaps the filament had burned out, so it was no longer able to, all those parts were no longer connected. What could be another way? Let's say I had a light bulb that worked, and when I was at home this summer and I screwed it in, why do you guys think that it didn't light up? What would be another reason?
You didn't have the switch for them.
I didn't have a switch? Okay, yeah. What about another reason?
We said maybe like screwed it in kind of crooked so that all 6 parts weren't touching connected.
Excellent. So maybe when I screwed it in, like the base wasn't touching right or the tip wasn't touching right. Yeah, nice use of vocab. All right, so you guys solved our investigation question. Isn't that awesome? Are you excited? Don't you love assignments? Sorry, I get excited about this stuff. You're like, okay, pull out the gold sheet, and what I want you to do is talk with your colleagues about how the lesson that we did together, talk about the parts. So there's an engage phase, there is an explore phase, there's an explained phase, and on the back there's an elaborate phase and an evaluate phase, which I didn't really evaluate you, but you all will be evaluating your kids. So, and hopefully think about the article that you read for today, the 5E, which is what we just did, and I modeled for you. Talk through what were the different parts, what happened in the engage phase, what happened in the explore phase, what happened in the explain phase, and I'm going to write a list up here on the board, okay? So share with your partners about the different parts of the 5E of the circuits lesson.
Rewind instead of maybe kind of doing like why that
I thought it was interesting how she like jumped the story of the summer and like had friends like with
it's like relatable. Yeah, it's like more relatable. Like it's not boring. It's not boring. Like a YouTube website about like the distribution. That's cool.
And actually, the explore phase was like the explore was like when we actually like
wrote down the
I think like where we I think that could be both explorers
more like elaborate with
like when she was planning it while you're exploring it. Vice versa. And then also like going back and like whenever you're doing
Okay, so let's come back together. What happened in the engage phase? What did I do that you will be doing in the engage to engage the students?
Well, you had a light bulb, so like whenever you first like looked like right here with it, I was kind of like, oh, I wonder like why she's carrying the light bulb around, and then you started telling us a story that like it wasn't boring, like it made you kind of want to know like why you couldn't get it to work the first time.
Yeah, great. So I told a little story. I used a little prop. Taylor, did you want to add to that?
I was just like, tell a story.
Yeah. Anything else?
You asked us questions. And like touched on our previous knowledge of light bulbs and circuits, kind of.
Yeah. So I would say activated prior knowledge. Got you thinking. Okay. Got you thinking about your own use of light bulbs. Got you thinking about when you've changed light bulbs. Great. What else happened in the engage part? Couple more things. Yeah, so students wrote predictions. What else? What else?
Well, you kind of just explained what we're going to do.
Yeah, okay, great. How did I do that? So I established a purpose for what we were going to do by saying something. Remember what it's called? Stating the... Starts with an I and ends in Q. You got it. So I stated IQ. We which is the investigation question, and that provided a purpose for our learning. Great. Anything else in the engage phase? I think you guys shared your ideas with each other, right? Okay. All right. What about the explore phase? What happened in the explore? What did we do first? Kathy?
Looked at our materials.
Yeah, looked at materials. What else?
Determined how we were going to collect the data.
Yeah. Great. What's another word for we have lots of different kind of vocab in this class. We've got data. What's a word that's synonymous with data? Like the same thing as data?
Information.
Yeah, information would be one. Good. Other ideas? I'm thinking of two specific ones. One that starts with an O and one that starts with an E.
Observations.
Yeah. So observations, and then what's that E one?
Evidence.
Yes. So we often use those interchangeably. So determine how to collect data, observations, and evidence. Okay. What else happened in the explore phase? I guess you actually collected that stuff.
Like common words, the
Yeah.
technology.
Great. So we can say like scientific language, common terms. Great. So we determine scientific language, common terms. What else happened? What was I doing? We didn't really talk about this yet. But Taylor, go ahead.
I was gonna say like modeling what we were gonna do if you had him take out the stuff in the box that we were gonna be using.
Yeah. Okay, so this is interesting. Now, I'm really glad you brought that up. So many of us have thought a lot about direct instruction. This class focuses on inquiry-based instruction. It's a little different. And in direct instruction, the teacher models. So my question to you is, did I show you what to do and how to do it? What did I show you? Like the materials. And I had you talk about how you're going to organize your data. So that's important, okay? So when you teach science, you don't like show them all the steps of the investigation because you want the kids to do some of that, right? You have it be scaffolded, supported, but you don't actually give away what they're going to find out. So I modeled how to use the materials. Like that. Modeled how to use materials. Good. What else? What else happened in the explore phase? Oh yeah, what was I doing? What was I doing in the explore phase? Did you notice?
We were walking around to different groups and facilitating discussion.
Yeah, so teacher circulates. And say it again.
You're facilitating discussion amongst a group of people of like what was working and what wasn't in line.
Facilitate discussion, ask questions. Now, often when we do the explore phase, as new teachers, we're really, really focused on students' behavior. What I want to challenge you guys to do is, yes, we need to be focused on students' behavior, but we're also going to be focused on students' thinking. So when I was circulating, I was saying, or I don't know, what was I saying? Did you guys notice? Do you remember? What was I asking you about? Does anybody remember?
I feel like I heard you say, how do you see this working? Or, you had us, further analyze what we found.
Yeah. So asking you how questions, asking you questions about what you found, asking you questions about what you didn't do.
I remember you saying that there's 4 ways to get on the light. And So that was like, oh, I found 2 ways, and I need to find the others.
Yeah. So providing some support, but not giving away the answer. Okay. So that's something we're also going to work on is how we can circulate and support kids' thinking and helping them. So like Cameron and Steph, do you guys remember what I asked you all? Can you share?
I think you just like asked us like, have you tried all of the parts? I don't
So,
remember
what's
exactly.
not connected.
What's not? Yeah.
Yeah. And just helping you focus in on the different parts of the light bulb, and you realize without me having to tell you what, like that you weren't connecting the base, that you weren't testing the base. Great. Anything else in the Explore? So you do it. I mean, I guess that's kind of obvious. Kids, you know, students do investigation. You made and record those observations. Anything else? I guess pretty good. Okay, how about explain? Now the explain phase. What happened in the explain phase? The explain phase is probably pretty new to many of us as science teachers and learners. I don't know, maybe not. What do you guys think? Do you think in your experiences learning science, did you have opportunities to do a lot of explaining? Or was it mostly getting excited and doing it? I don't know. What happened in that explain phase? What did we do in that explain phase?
Reflect.
Okay, we reflected. Great. So walk us through. What did we do to reflect? Or someone add on to what Abby's saying. What did we do to reflect? What was the first thing that we did, Abby?
We like wrote a claim and thought back to what worked in the investigation.
Okay, great. We wrote a claim. But hold on, we did tons of stuff before we wrote the claim. The claim, because writing a claim is hard, right? So we wrote the claim. We'll add that down here. Wrote claim. Now, we did lots of stuff before we wrote the claim. What, can someone, what do we do first? Savannah.
We did like on the board right there, the class, like information, like
Yeah.
so what worked and what didn't work.
Great. So we recorded data on board. Great. So we recorded data on board. That's the very first thing we did. Okay. So when you're teaching science, you'll get all the kids' observations and you'll get them on the board. You'll represent them on the board so that then you can make sense of the data. So after we had the data on the board, what do we do next?
Compared what we had and what worked and what we had and what didn't work.
Okay, great. What's another word for that? Like kind of
Compare and contrast. Results.
Compared data. I like that. Compared data. There's some other scientific-y sounding words.
We found patterns.
Yeah, there's patterns. Like we identified patterns. Great. What would be an example of a pattern that we noticed?
The 6 parts that we like decided were the important aspects.
Yeah. So we identified patterns. Okay, great. What do we do next? For the data, we identified patterns. Yeah, what do we do next? You have thoughts? Anything else? Wait, we went to claims? Is there anything we did before we went to the claims? Did we say we went to claims? Okay, so here's the row of the claims. Row claims supported by evidence, right? To answer, We wrote the claim supported by evidence to answer what? IQ. Good. Just want to make sure you guys aren't asleep. I know it's a long morning. We're almost done. Okay, so it's the explain phase. Recorded data on the board. Compared data. Wrote claim supported by evidence to answer the IQ. And then the elaborate, the very last one. What happened in the elaborate phase? Remember? Did you catch that? It was pretty quick. The elaborate phase.
That's when you connect the prior knowledge to the new knowledge that you're learning.
Yeah. To make connections between your prior and your new knowledge. Yeah. What else happened in the elaborate?
Is that when you talked about what would happen if this didn't work or this wasn't? You know, like
Yeah.
the battery was dead or
Yeah, exactly. So we talked about, hey, if that battery was dead, would it light up? Yeah. What was something else that we did in the elaborate? We returned back to something. Return back to our predictions. Anything else? Turn back to something else. Remember? The hook, the story. Return back to that to kind of answer that question. Why didn't that light bulb work when I tried to replace my light bulb this summer? So the elaborate was returning the predictions, returning to that story, kind of making all those connections. Oh yeah, you know what we need to add? We forgot something here. We forgot that reasoning. We wrote the reasoning too here. Which was pretty much, that's the scientific principle. And what was our big scientific concept that we learned in our lesson? Yeah, what's a circuit? What's a complete circuit? Okay. That is the 5E framework, and an engage phase, eliciting and engaging students' initial ideas. Explore phase, helping students make and record observations of data as they explore the phenomenon. Explain phase, helping them notice patterns in their observations and using those to write evidence-based explanations. Elaborate, helping them apply knowledge to new problems or old problems. And the evaluate, well, we didn't really do, but that's, assessing students' knowledge. Those are your 5E phases. Okay, so that's the 5E. This class, you will be learning how to teach in the 5E. You'll be teaching an hour-long 5E lesson with elementary kids at Fremont Elementary. And what are your reactions to teaching science in this way? Just talk with your partners. What is your reaction to teaching science using the 5E framework?
I remember she would just go up there, she would do the whole thing, and then you would go through the rest. So it's kind of, I feel like it wasn't, I liked it. Because you introduce yourself to people, I guess it was a joke, like, you didn't really, I just remember not really thinking about it.